Ahoy hoy, I'm Planet Walk, and recently I came across a Flat Earth video that makes an argument that I actually hadn't heard before, and the Flat Earther making it at least appears to know what he's talking about, which is a difference when it comes to Flat Earthers. Now, of course, I do wonder how much the Flat Earther actually knows what he's talking about, because there are a few issues that really shouldn't be made, but we'll get to that. But to start off with, let's let Taboo Conspiracy explain what's going on here.
In short, we are going to show with 3D modeling software how sunrises and sunsets prove the Earth is flat.
You want to know what's funny? People have used 3D modeling software before to show that sunset and sunrise are simply not possible on a flat Earth. It is very weird how they'll ignore that, yet go on to make videos like this.
Of course, flat Earth doesn't mean there aren't oceans, mountains, valleys, terrain, etc. The term flat Earth means that there is no Earth curvature, no globe, no ball, and no outer space.
I think most people know that already, but maybe there are a couple of flat earthers out there that literally believe that reality is 2D and not 3D, and that we're all just 2D creatures that don't realize that we're 2D creatures or something. That'd be a very weird belief to hold.
A huge thanks to Paul for making the video you're going to see in a few minutes. Paul was inspired to share the truth, and he has stepped up and spent a long time using his expertise to develop this model without any compensation. Paul is an engineer and computer graphics artist who owns a 3D product animation studio.
Okay, in that case, I really hope that there's nothing there that shows that he might not be quite as professional as you'd hope. It'd be quite embarrassing for a professional 3D artist to show that they don't know about, let's say, professional 3D lighting, for example.
If the globe were real, then the sun must set at an angle lower than the observer's position until the sun drops physically below the observer's feet. That is the simple official narrative. This is the same claim for those few geocentrists who still believe in the globe but claim the Earth is stationary while the local sun and moon rotate around the Earth.
Okay, that is interesting because you don't often hear flat earthers admit that not all geocentrists are flat earthers. Usually they like to conflate the two, despite them not actually being as synonymous as flat earthers would like to have you believe.
On the other hand, flat earthers claim that the sun never sets at an angle lower than your feet. Generally speaking, flat earthers claim the local sun does not physically rise and fall, but simply travels further away from the observer. The sun's apparent setting is caused by perspective and the limitation of the sun's light. What's important here is that, according to the flat Earth model, the sun cannot actually travel below the flat Earth and will never be angled below your feet.
Okay then, model that in 3D software, because I can tell you that when I have done that, the sun never sets. It is always visible in the sky. The problem that flat earthers would have with that is they would have to literally design a new type of perspective, because the perspective that everyone uses would not allow for the sun to set. Oh, and just to address the sun getting smaller and disappearing, this is a light. It is not as big as it appears in the camera. See, when I point it towards the camera, it is a lot larger, and when I point it away, oh, it's a lot smaller. That's because of glare. If you were to take those videos instead using a solar filter, then the sun would be a much more consistent size throughout the day, not getting bigger or smaller.
What started all of this was the fact that many globe propagandists have claimed that shadows, like this one of Mount Rainier, are showing an upward shadow of the mountain being cast by a sun that's below the physical horizon. Remember, these globe proponents are claiming the sun is lower than your feet, below the Earth's physical bulge, proving the globe. In fact, what you're seeing here is the top of the mountain casting a shadow on clouds that are physically below the peak. Due to perspective, from a lower vantage point, it only appears as though the mountain shadow is angled upwards.
Okay, here's a question that I have for you. Did you actually, look at the photos that you showed on screen there? I ask that because if you look at this photo here, you can quite clearly see that the clouds are not below the peak, as evidenced by the fact that the shadow is a fair distance away from it. I didn't have to go to google.com to find that picture. You put it in your video. Did the underlining of words distract you so much that you didn't realize that you put that picture in your video or something?
We can say this definitively because there has never been an upward mountain shadow filmed from the apex of a mountain.
There is a reason for that, and that is it's quite difficult to get those photos when you're at the top of a mountain. Firstly, you need to actually get to the top of the mountain, because otherwise you wouldn't be at the top of the mountain. You also need to make sure that the clouds are above you on the day that you do decide to go there, but you also need to make sure that there are no clouds stopping the mountain from casting a shadow on the other clouds. This will actually be quite important when I explain what I did in Blender. That's for later on in the video though.
What's ironic is that this mistaken globe evidence just became the death knell for the globe. You can't have an upward mountain shadow and not have a similar upward Earth bulge shadow causing a similar and noticeable effect. In fact, the globe requires an upward bulge shadow, and that's what we're going to show here today.
You know, when I first heard that, I wondered if Taboo Conspiracy had forgotten the concept of, night, when we're in the shadow of the Earth. Fortunately, he's going to explain a bit more about what he means. What the? Oh. That's a thing, isn't it?
Recently, I came across a fascinating set of videos regarding the phenomenon of the apparent shadow casting from Mount Rainier onto some clouds. These videos are from the YouTube channel Taboo Conspiracy. He does some great flat earth videos, so I was eager to hear what his thoughts were on this phenomenon because on its surface, it appears to indicate a globe model. I mean, if the sun can cast a shadow vertically, that would indicate that it is in fact going below the horizon as the globe model claims.
Yes, and the fact that Taboo Conspiracy included this photo indicates that that is the case. Basically, by saying what you just said, you are confirming, based on Taboo Conspiracy's very own video that you've been included in, that the Earth is a globe. Unfortunately, I don't think flat earthers are going to realize that.
In this video, he showed this image. Basically, if the Earth was a globe and the sun was falling over the horizon as the Earth spins, we should see the globe shadow itself shine up on the clouds. This made sense to me, but I really wanted to test it out. So, with my background as an engineer and a CG artist and my familiarity with computer graphics tools, I set out to mock this up with the intention of seeing if this would actually happen.
Okay, I've got a question, and I don't think Paul is going to be watching this video, but if you are watching this video, hi Paul, here's a question to you. Did you mock this up on a flat Earth at all? I ask this because attempting to show that the globe isn't real and that the Earth is flat are two different things. One is showing that something isn't true, and the other is showing that something is true. It's like if I were to show that this wall here isn't made out of wood. That doesn't mean that it's made out of plaster. It could be made out of bricks or something. Likewise, if you show that the Earth isn't a globe, that doesn't mean that it's flat. I think a better thing to do would be a comparison between what you'd expect to see on a globe and what you'd expect to see on a flat Earth. Whichever model is closer to reality is more likely to be the more accurate model. And I can tell you right now that the flat Earth model, just by going off 3D graphics technology, is not likely to be the accurate model.
This experiment, the nature of typical CG lighting in a, quote, realistic render package is problematic because they typically have a light intensity fall off baked in. As you get further from the subject, the light intensity has to dramatically increase. At the distances proposed by this globe model, the CG programs really can't adequately represent them. The early days of CG lighting, there was a concept of it's called direct lighting, which basically the light doesn't lose power based upon distance. The light itself also has parallel rays and is supposed to simulate the sun from far distances. Luckily, we can replicate the sun in this experiment with a direct or infinite light. See here the harsh shadows that are cast, and as I move the light away, there is no effect on lighting intensity or the shadow sharpness. What does affect the shadow is the angle of the light. So this will be adequate for this experiment. So I built the model with two known caveats. The model would be scaled and the sun would be a direct light with the infinite parallel rays. Overall, this is not a compromise because the experiment is really to see if the globe/ball would also cast a shadow on the clouds as the sun went down.
Okay, so the model being scaled down is completely fine as long as the proportions are correct. In fact, I have scaled down models in the past. In fact, with this image that I created of an eclipse and another image that I created of Jupiter, I have scaled those down, so I'm not going to critique you on that. What I will say though is that lighting can be super tricky to get right, and he was right when mentioning that computers use all kinds of shortcuts so that you can get somewhat accurate looking lighting. In fact, with the image that I showed earlier, I used a whole lot of point lights to simulate the sun, and that made the render times shoot right up. Now what I wonder about is the directional lighting in the program that he's using. In Blender, you have the option to create a sunlight, which is essentially a directional light. Now, when you go ahead and create that light in Blender, it has a value on it called angle, and by default, that is set to 0.5. Now, what does this do? Well, it softens the shadows up a bit. In fact, I'm pretty sure the 0.5 value is basically the angular size of the sun. Now, the reason why this is important is because not all of the light comes in parallel. Some of it comes in at a slight angle because the sun isn't just a single point in the sky, it has a size. Now I looked very closely at your screen and it turns out that the directional light does actually have this ability, and it's called spread. The value that it was set to is 0.0 degrees. Now Paul, if you're watching this, did you use that value for the final render? I would hope not. I would hope you'd have more expertise to know that you should at least have a bit of spread there. Now I did check over the rest of the video because, you know, maybe he did change the properties of the light later, but I couldn't see that, so that's the first thing to be skeptical of. However, there are more lighting shenanigans that a professional should know, but we will get to that.
Really important to build a replica as much as necessary. These principles are really about angles, line of sight, etc. So the essentials to do this, in my mind, were as follows. A scaled Earth globe, a suitable light source such as direct CGI, a cloud layer, a scaled version of the mountain, and really the approximate location and orientation of this photo, the point of view from which this whole thing took place. So the next question was, where was this photo actually shot from?
Okay, I will give him some credit here because that is a lot of effort to go ahead and try and recreate a photo, more than actually what's necessary to try and show what you're trying to show. So, you know, you went over and above. I'm going to give you points for that. Unfortunately, because you recreated it so well, we are going to be able to point out errors later on.
So, if you zoom out over the whole entire site, this area is what I needed to replicate and build in 3D. So here's the sphere Earth model scaled 1 kilometer to 1 meter. You can see here the radius is 6,371 meters. As we zoom way down into the model, we'll see Mount Rainier. All of this data for Mount Rainier and Tacoma are from DEM data sources, and they have been scaled to 1 kilometer to 1 meter. Finally, taking all this information into account, let us compare our scene setup with the actual photo. For this experiment, this is more than adequate to demonstrate the concept of a globe bold shadow.
Okay, there's a problem here, and I'm going to say something that is going to be easily taken out of context. But Earth is not a sphere. Now what I mean by this, of course, is that Earth is an oblate spheroid. The setup that he has there is to try and debunk a sphere Earth, albeit one with a couple of mountains and a few buildings. But primarily, the video that he made is to debunk the idea that Earth is a sphere, which it is not. It is an oblate spheroid. This goes back to my point earlier. Let's say that you do debunk Earth being a sphere. Well, that doesn't mean that it's flat. It could still be an oblate spheroid, for example. Now, why is this important, you may ask? Well, you see, if the Earth is supposed to be casting shadows on the clouds, the mountains that are way off in the distance are part of that Earth. So really it is the mountains and stuff that will be casting shadows on the clouds, and that will make the shadows on the clouds look uneven. Nothing is modelled past Mount Rainier in his model. And what's more is that in the photo of Mount Rainier that he's modelling his scene after, you see some of the mountains that are missing. You know, this is reminding me very much of the whole frictionless spherical cows meme. I hate to break it to anyone out there that might believe in frictionless spherical cows, but they do not exist.
Now we arrive at the scene. It's early morning and the sun is rising in the east. The conditions are perfect to see this rare phenomenon of the mountain casting the shadow on the clouds. Let's see what happens. As you can see, as the sun rotates up, it does in fact interact with the spherical Earth and cast a shadow on the clouds from underneath. Our experiment was set up to mimic the Earth as a sphere, the exact size and conditions for a shadow from Mount Rainier on the clouds, and the hypothesis that as the Earth rotates, the sun goes down below the Earth. If the Earth were a ball, this is what we should see under these special conditions. In fact, if the Earth were a ball, we should probably see this almost every night in some fashion or another.
Okay, now that we've seen what it's supposed to look like, we can go ahead and view some of the animations that I made. Now, I am not as much of an artist as this guy, so mine are very simplified. But they will get the point across. Now, one of the first things that I did was make sure that the spread angle of the sun was 0.5. That is very important. I don't know if he did that. But secondly, I made sure that the undersides of the clouds were not flat because, you know, the undersides of the clouds in real life are not flat. So what I did is I created a plane that was heavily subdivided. Then I added a texture to it, a clouds texture. However, this texture was for displacement. I also added a very simple Mount Rainier, which is basically a cylinder with a few subdivisions. I feel like the team skeptic of 3D graphics. Anyway, this clip is what I ended up with, and there was a bit to improve. Firstly, the sun rose way too fast, we had to slow that down, but there was something else that I noticed with the clouds, and that was that even when the sun was probably above them, they still appeared to be lit up. Now, this is not a problem. All I have to do is make sure that the sun doesn't go above them. Easy. However, we can utilize this little trick for something that my first render attempt as a test didn't use. Now this is also something that Paul didn't use, because if you notice with Paul's render, none of the buildings change brightness. I am of course talking about ambient lighting. Now in Paul's render, there was some ambient lighting there, but it stayed consistent throughout the scene. Now I take issue with this because, to me, there is something that you should know if you're doing any kind of 3D graphics, especially professionally. And that is that the ambient lighting is higher during the day than it is during the night. Because the sun's out during the day and there is a lot of atmosphere to scatter it around. This is going to affect how everything looks. You should include some kind of dynamic ambient lighting, which in my second render, I did. So for this render I used an area light for ambient lighting, and I also made the sun go a lot slower. Now, I think I was a bit too conservative with the ambient lighting in that, because ambient lighting isn't exactly subtle. It's something that actually, during the middle of the day, makes things very bright. So I kicked it up a notch for the final render. So in this one, the sun goes even slower. But also, I added a lot more ambient lighting, because, you know, ambient lighting isn't subtle, as I mentioned before. So that is the final animation that I did. I could improve on it in some ways, but if I wanted to do that, I'd also be waiting for several hours for my computer to churn out another render that would also take up another 3 GB because of the uncompressed files. Now the thing that seems to make the most difference here is the ambient lighting. Of course, the clouds not being flat also makes a huge difference. My question is, how does a professional 3D graphics artist miss that kind of thing? Aren't you supposed to have things like 3-point lighting to make your scenes look more realistic? Look, I'm not a professional 3D artist by any stretch of the imagination, hence why my animation looked very crude. However, there are issues that me, not a professional, can point out. I feel like that should have been included in the video.
For a closer look at what's going on, let's go back to the schematic. If we pause the sun rotation right here where the shadow crosses the cloud layer just to the west of the mountain, here is the image of what we could expect to see. This experiment is a serious blow to the globe model. After working through this experiment, this is another in a long list of proofs that people can do for themselves. Each one of us can go out each morning at sunrise or each evening at sunset and observe this for ourselves. Do you see this shadow across the sky? For me, I've never experienced this visual in my life on this plane, nor have I seen any photos of this phenomenon to date.
So yes, we don't see that, because that's not what we would expect to see. Reality works different to what you've modelled. Fortunately though, I have chosen a frame from my animation, one that I think looks somewhat similar to reality. Let's compare this to one of the photos of Mount Rainier. Oh. Now, my recreation here is by no means perfect, but it did surprise me how accurate to reality I managed to get it. But here's the kicker. He didn't do this for Flat Earth. We're just supposed to assume that the Flat Earth version is more accurate to reality. So between my simulation, which actually manages to get it fairly close despite using a frictionless spherical Earth, and his non-existent Flat Earth simulation, I gotta go with my Globe Earth simulation. So we did it. We showed that the Earth is closer to a frictionless sphere than it is to a flat Earth. Who would have thunk? But you wanna know what's funny? He didn't use any video to reference his animation against. All we have to go off of is, oh, which frame do we think matches the photo? But anyway, that is it for this video, and I know that there are going to be people saying that you missed this explanation, you missed this explanation, but light is complicated, I got the basics. Look, the point of this video is that Earth is a frictionless spherical cow, okay?